Hey everyone, and welcome. Today, we're going to learn a new language. And no, I'm not talking about Spanish or French. This is a language that describes, well, pretty much everything. From the engine humming in your car to the stars burning billions of miles away, we're learning to speak the language of energy itself. Thermodynamics.
So how do we do that, right? How do we actually speak this language? How do we get fluent in the rules that run our entire universe?
Well, a lot of people hear thermodynamics and they just think of crazy, complex math. But at its heart, it's really a descriptive language. And like any language, if you want to get good at it, you've got to start with the basic vocabulary.
So here's our game plan. We'll start with the basics of this language. Then we'll learn how to define what we're talking about, our system. After that, we'll get into how to describe it, how it changes, and how those changes can form a repeating cycle. And then we'll be ready for the big stuff, the universal rules. Let's dive in.
Okay, first up, the language of energy. We're starting with the absolute fundamentals. Think of these as the building blocks for literally every single conversation we're ever going to have about energy from here on out.
So the very first word we need is our noun, the subject of our sentence. In the world of thermodynamics, we call this the system. It's simply the piece of the universe that we've decided to zoom in on and study.
And that leads us right here. Before we can say anything meaningful, we have to define our focus. We need to know exactly where our subject begins and where it ends. And we do that with three key ideas: systems, surroundings, and boundaries. Let's make this super simple. Imagine you're studying the gas inside a car's piston. That hot, compressed gas, that's our system. Everything else, the metal piston, the engine block, the air in the garage, that's all the surroundings. And that thin inner wall of the piston, that's the boundary separating the two. See? Simple. We've just put a frame around what we're looking at.
And this is a really crucial point. You simply cannot analyze something if you haven't clearly defined it first. Drawing that boundary is always step one. It's what lets us take a huge, complicated universe and boil it down to a problem we can actually solve.
Now, systems come in a few different flavors, and it all comes down to how they interact with their surroundings. First, you've got an open system. Think of a turbine. Air and fuel go in, exhaust and power come out. Both mass and energy are crossing that boundary. Then you have a closed system, like a sealed, rigid tank of gas. You can heat it up or cool it down so energy can cross, but no mass can get in or out. And finally, you have the ideal case, an isolated system. Nothing gets in, nothing gets out. Think of a theoretically perfect thermos. It's a useful concept for understanding the big picture.
Okay, so we have our noun, the system. Now, just like in English, we need adjectives to describe our noun. In thermodynamics, we call these adjectives properties, and they tell us all about the system's state.
A state is really just a snapshot. It's the system's exact condition at a single moment in time, and we define it with things we can actually measure, things like its pressure, its temperature, or its volume. Those measurable things are its properties.
And these properties come in two main types. You've got intensive properties, which don't care at all about how much stuff you have. Temperature is the classic example, right? The temperature of a single drop of water can be the same as the temperature of the entire ocean. But then you've got extensive properties. These depend completely on the size or mass of your system. Things like volume or total mass. Obviously, a full glass of water has more volume than half a glass.
So we've got our nouns and our adjectives. It's time for the verbs. We need the action words. How do we describe movement and change? In thermodynamics, our verbs are called processes.
A process is just the journey a system takes from one state to another. Anytime one of its properties changes, the temperature goes up, the pressure goes down, a process has happened. It's the path between those two snapshots we were talking about.
Let's go back to our piston to see this in action. It starts off in an initial state, right? It has a certain temperature and pressure. Then we do something. Let's say we add heat from a flame. That's the process. What happens? The gas expands and pushes the piston up. And eventually it settles into a new, stable, final state with a different temperature and pressure. That's the whole story right there.
But what if the story doesn't just end there? What if it loops around and starts over? That's how we get from a single process to a complete, repeating story, the cycle.
A cycle is exactly what it sounds like. It's a series of different processes that are strung together, but the key is that the very last one brings the system right back to its original starting point. This is absolutely essential for things like engines or refrigerators that have to run over and over and over again to do their job.
You can see it right here on the screen. We're at our starting state.
Then process A takes us somewhere new, to state 2. Then process B takes us somewhere else, to state 3. And then a final process C brings us right back home to where we started. The whole story is now ready to repeat. That's a cycle.
Okay, let's just take a breath. We've just learned the core vocabulary of thermodynamics. We have our nouns, systems, we have our adjectives, properties and states, and we have our verbs, processes, and cycles. We are officially ready to start forming complete sentences and understanding the story of energy.
And this isn't just an academic exercise. This language we've just learned, it's the key. It's the tool that lets us unlock and understand the fundamental laws of thermodynamics, the grammar that the entire universe follows.
And make no mistake about it, I love this quote because it puts it so perfectly. These rules we're about to get into, these aren't just suggestions. They are the inviolable laws that govern every energetic interaction in the universe. These are not theories you can argue with, they just are.
So now that you can speak the language, the real conversation can finally begin. We've covered the vocabulary, and next come the universal rules. Thanks for sticking with me through this explainer. My only question for you is, are you ready to learn the laws?